Good morning, students. In the previous video, I have covered some numerical examples based on the damage analysis. So we have completed our first unit, we can say, in which we have done the error, dimensions and the measurement part. Now from today, we are entering into the very important part of physics known as mechanics, or it is also known as Newtonian physics. Mechanics is divided into two parts, first kinematics and the dynamics. So here we are doing the chapter known as motion in one dimension. Motion in one dimension, it comes under the category of the unit kinematics. What is kinematics? Kinematics is basically study of motion or rest. In this we'll see how the body is moving, what is the distance covered by the body, what is the speed or velocity of the body, what is the acceleration. But in the kinematics, we do not study what causes the motion, right? If we say the body is moving with, let's say, 10 meter per second acceleration, right? Or we say that if you throw a ball from some height, then it moves along the gravity with acceleration 9.8 meter per second square. So by using the different formulas and different equations, we can find the distance covered by the body in a certain interval of time. We can find what is the final velocity of the body in that certain time instead of time. But we will not discuss what causes this acceleration. It means we will not study the gravity here, because gravity is the reason why the body is accelerating. So in kinematics, we only deal with the study of motion or rest, but will not study what causes the motion, that is the reason behind the motion, that is force, right? That will cover in the part dynamics. So in this chapter, we calculate the displacement covered by the body, distance covered by the body, velocity. To calculate these quantities, the position of the body is very important. Suppose I say that I have covered 3 kilometers. Now 3 kilometers from where? There must be some starting point, there must be some ending point. That means there must be a point from where we have started the measuring the distance. So to solve this problem, we use a term known as, see, physical quantities like velocity or displacement, they required some coordinate to define them. Some coordinate must be assigned so that we can define that this body started the journey from this point and going from that point, right? Now to describe these coordinates, there must be some reference. Suppose when we solve numericals, when we solve some question mathematics in the coordinate geometry, we say the coordinates of point X is of point P is 2 and 3. When we say coordinate of point P is 2, 3, then we must have a coordinate system like this. This is Y, this is X, and this is Z. Now where will you put these 2 and 3? There must be some reference point. So we assign these coordinates with respect to the point which is known as origin. Now with respect to this point, we'll move 2 points in the X. Let's say this is 0, this is 1, this is 2, this is 3. So this will be the X, and 1, 2, 3. So when you, this is the coordinate of the point P, right? Now to assign these coordinates, there must be some origin, there must be some reference. because without reference, how can you calculate that we have moved 2 unit in the x and 3 unit in the y? There must be some reference. So to assign these coordinate, we select a point known as a reference point, and this complete system is known as frame of reference. Frame of reference can be anything. Suppose I am sitting in my room, so that will be, the room will be the frame of reference for me, and where I am starting, that will be the origin. I can measure the distance of different object from my room from this point, right? So this will be the point of the reference for me. Now suppose if I change my point of reference, now I am standing here, then obviously the distances or the measurement of all the object will be changed, because I have changed my point of reference, right? So that means the position of the quantities depends upon the point of reference and the frame of reference, right? Now, frame of reference can be of two types. First, known as initial frame of reference, second known as non-initial frame of reference. Now, what is the difference between them, and what is the initial and what is the non-initial frame of reference? Let's understand this. Inertial frame of reference. If in any frame of reference the Newton's law is applicable, it works according to the law given by the Newton, then it is known as inertial frame of reference. Every frame of reference which is stationary or moving with constant velocity will be regarded as inertial frame of reference. Why the constant velocity? Why not the accelerating frame? That we'll discuss in the chapter Newton's law. That is the fifth chapter, I think. So here you understand, if any frame is stationary or it is moving with a constant velocity. When I say constant velocity, it means the speed of the object is constant, plus direction is also not changing, because velocity contains speed as well as direction, magnitude as well as direction. So velocity constant means the body is moving in a straight line, and then the velocity of the body will be constant. So any reference whose stationary and or moving with constant velocity can be regarded as the initial frame of reference. For example, let's say I'm in a room. So this room for me can be regarded as the inertial frame of reference. Suppose you are sitting in a train, and train is moving on a straight rail and the velocity of the train is constant. Then the compartment of the train will be regarded as the inertial frame of reference. Or let's say an aeroplane, it's flying in sky in straight line, but there must be no acceleration in the plane, because if there is acceleration, then it will not considered as the inertial frame of references. So a plane moving in a straight line with constant speed will be also regarded as the inertial frame of reference, because in all of these reference we can apply the Newton's law. Okay, like the Earth, all the laboratories can be regarded as the initial frame of reference, but practically Earth or anything which we say that it is stable on the Earth, is not actually stable, because we know that Earth is rotating on its axis, right? It is rotating on its axis. That means it have some acceleration. It have some centripetal acceleration, because in the class 10th we have discussed when the body performing circular motion, then it acted upon by an acceleration known as centripetal acceleration. So when Earth rotates, it all of us have some value of centripetal acceleration, right? So practically it is not an inertial frame, but when we calculate the value of this acceleration, it is quite small. It is too small so that we can neglect in our calculation. That is why this Earth can be taken as inertial frame of reference. Okay. Now let's talk about non-inertial frame of references. So obviously, opposite to this, that means if the inertial frame of reference is accelerating or retarding, that means it don't have a constant value of velocity, then it can be regarded as the non-inertial frame of reference. Non-inertial frame of reference. In this case, laws of motion is not applicable. All right, or they do not obey these laws, and velocity is not constant. So any frame which has some retardation or acceleration, or it is rotating on its axis, because suppose this room start rotating on its axis and the speed of the room is, let's say, constant. It is rotating, if the linear speed is 2 meters per second, but as the room is rotating, that means the room is changing its direction continuously, and if room is changing direction, that means the velocity is not constant. So when we say velocity is not constant, so this case is already included here, right? I am writing here in the next case also that frame is rotating. So if any of these, so this is the condition, and if any of these two conditions are with the frame of reference, that means it is considered as the non-inertial frame of reference. The name of the chapter is Motion in One Dimension. Let us understand motion first. Motion. Everything in the universe are in motion. From the time of the Big Bang, everything in the universe is moving relative to each other. If we are watching anything that body is stationary, that is stationary with respect to us, but it is also moving from the frame of our universe. If we say that Earth is stationary, but it's not, it is moving around the sun. If we say that sun is stationary, no, sun is not stationary, but it is moving, or it is completing circles around our galactic center. If we say that our Milky Way, our galaxy is stationary, again it's not true. All the galaxies in the space, they are moving with very high velocities. They are moving related to each other. As you know that our nearest galaxy, Andromeda, after some billion years, the Andromeda and our Milky Way galaxy, they will collide with each other. So that means our galaxies are also not stationary. The whole universe is expanding. That means the smallest of the particle of the universe, as well as the large stars, black hole, and every galaxy, everything is moving away from each other. So the first thing, that everything is in motion in the universe. But when we study in kinematics, we are dealing with any quantity which is let's say outside our galaxy. We are only calculating, or we are studying the objects which is either on the earth or they are connected to the earth, right? So what will be the definition of motion? First thing, motion is not the absolute quantity. It's a relative quantity. Absolute means if you measure a quantity from one reference or from the one observer, let's say value is x, and then you measure that quantity from some other point or from other observer, value is again x. If both the results are similar, then we can say yes, this is a relative, this is a absolute quantity. For example, if you calculate the temperature of this room, then either if I'm standing here and I measure the temperature, it will be, let's say, 28 degrees Celsius, and if I stand here, it will be again 28 degrees Celsius. If I go to any corner of the room, the temperature will be same. That means that temperature is an absolute quantity. But motion is basically relative quantity. It is not absolute, because it changes with the observation according to the observer, right? Suppose I'm standing here and you pass by me, then for you, suppose you are passing on the road and sitting in a car. So for you, I'm moving backwards, right? That means for you, I am not stationary. But if any person who is sitting in the room will, when he see me, then for him, I'll be stationary. So body is stationary when body will be moving from that point of reference. So here, motion depends upon the reference point and from where the body is being observed. What will be the definition? Definition is when the body changes its position with respect to its surroundings, then we can say that body is moving, right? Again, I'm saying, you can see here the definition of the motion: when the body changes its position with respect to its immediate surroundings. Let's say I'm right here. When body changes its position with respect to its immediate surroundings. Then body can be regarded as in motion. See, I am written here immediate. Why immediate? Because suppose you are moving and with respect to the distant star, will be regarded as stationary, because there is too much distance between that distant star and you. So that is why we are just observing this with respect to our immediate surroundings. What will be more? What will rest then? Again, it depends upon your surroundings, your observer or the frame of reference, right? So similarly, if you define the rest, it is also relative quantity, depends upon the observer, right? If I'm standing here, I'm rest with respect to you or with respect to the other person standing in this room. But if an astronaut observing me from the International Space Center, so for them, I'm not stationary because ISS is rotating around the Earth, right? If any person standing on the moon observes me, so I will be again not stationary because Earth is moving with very high speed. So if any body does not change its position, right? So I can change this definition. When body does not change, its position with respect to its immediate surrounding, that body is said to be at rest. So I think you have understand the concept of motion and rest. In the next video, I will talk about some important topics like displacement, velocity, average velocity and all. Till then, thank you so much, class.